Hello my dear students, this is Akash SD. Welcome to the ASD physics classes. Hopes you all are doing really great. So students, in this video we are going to solve the questions from the chapter work, energy and power. Okay, so let's go through the question. So the question is, can you see here? Consider a drop of rainwater having mass 1 gram falling from a height of 1 kilometer. It hits the ground with a speed of 50 meter per second. Take G constant with value 10 meter per second square. Now, the work done by the first one, gravitational force, and second one, resistive force of air is how much here. So, after reading this question, kindly remember that here the term is given resistive force of air, and this is the non-conservative force. So, whenever in the question non-conservative forces are involved, we have to think about one very important theorem. The name is the work energy theorem. That theorem only I am going to use. What I told you, work energy theorem. Okay. So, first let's note down the data. Mass how much is given here? You can see very well. The mass is given here 1 gram. 1 gram we can write here 1 by 1000 or 10 power minus 3 kilogram. Is it? After that, if we talk about here the height is given here 1 kilometer. Is it? So, we can write here the 1000 meter. Correct? After that, next one, if we talk about here speed, final speed. Now, let's take here drop is there. When the drop is falling, its initial speed is 0. And when it is striking the ground, its speed is Vf. Even you can write here Vi also, no problem, Vi. Okay. So, Vf how much is given here? You can see very well 50 meter per second. Okay. After that, G value anyhow 10 is given. So, first question when I see here, what is the first part? Gravitational force here. So, you know very well work done is always given by Fd cos theta. Gravitational force means gravitational force means work done by the gravitational force. Wg work done by the gravitational force. What is Fg? Gravitational force. Okay. So, you know very well the gravity is acting downward direction because this is the surface. So, when the gravity will act in downward direction, mg will also act on the drop in a downward direction. Now, what is the d? D is the displacement. Displacement acting in a which direction? This direction, because the drop is falling downward. Is it? So, both the arrows in which direction? Downward direction. Here theta how much here? 0. Theta is the angle between a force and the displacement. So, when I will write here, it will come Fg into d into cos 0. Cos 0 is 1. Okay. So, Fg how much here? Mg. And d how much here? H, and cos 0 is 1. So, it will come here mgh. M how much is given? We can tell very well here 1 by 1000. G is 10 and H is given 1 kilometer means 1000. Is it? So, 1000 anyhow cancel, and what it will come here students? 10 joule plus 10 joule. Why plus 10 joule? Because both in a downward direction. Can you see very well? This is the work done by the gravitational force. Is it? Even if we eliminate the options and all that, we know very well the option is going to be option C. Correct option is going to the option C. But why this work done by the air resistance is negative, and all these basics are involved here. Okay. So, as I have told you very well, in this situation, whenever the air resistance is involved, we will use here the work energy theorem. And what is the work energy theorem? Work done by all the forces is equal to change in kinetic energy. Okay. Which forces are involved here? One is the gravitational force, and one in the question they told the air resistance. Final kinetic energy, what we can write here? Half mvf square. Initial kinetic energy, as Vi is 0, so initial kinetic energy is 0 because the drop is just falling. Okay. So, from here, if I write here, this work done by the air resistance is given by, share the formula, half mvf square minus Wg. Okay. This is the formula we have got it. Okay. Now, after that, what we'll do here? We'll just put here the values and all. Okay. So, see here, half mass, you know, 1 gram, so 1 by 1000. And what is the speed? Speed, can you see very well? It is given here the 50 meter per second. Is it? So, 50 square means we can write here 2500 minus, and work done by the gravitational force, what was there? 10 joule. We have calculated. Is it? So, what this will happen here? Can you see here? This 0, this 0, this 0, this 0 cancel. Is it? So, we can write here, see, 25 by 2 into 10, 20 minus 10. So, 25 by 20 means we can write here 5 by 4 minus 10. Is it? So, 5 by 4 means we can write here, see, 1.25. Is it? Minus 10. Is it? That means students, we can write here this work done by air resistance is going to be how much here? Minus 10 plus 1.25. It is coming minus 8.75 joule. What is coming here? minus 8.75 joule. Kindly understand very well. Is it? And why? What is the meaning of the minus sign? The minus sign meaning is that when the air is not air, when the drop is falling downward, what will happen? That na, here please. This air resistance, na, air resistance will act in downward direction. Air resistance will act in upward direction, and displacement in which direction? Downward direction here. Is it? And here this theta will be 180 degree, and that's why what is coming? Work done by the air resistance is coming what? Negative, and that's why it is coming here minus 8.75 joule. Okay, can you see very well? And remember that here one word of caution I will tell you. One word of caution I will tell you. Remember that here. One more thing is there. We know that here whenever any object falls from the rest, this Vf we used to write here the 2gh, is it? But this formula, remember that here, this formula we have to only use when there is no air resistance. Air resistance is 0, then only Vf equal to root 2gh will use, otherwise we will not use it here. Okay students, so I hope so this question involving non-conservative force, and here we have used which one? Work energy theorem is very clear to you. Keep studying, keep growing.